Now we look into another method of factorization, that is factorization using algebraic identities. What are these identities which we use for the factorization? The very first one is a plus b whole square is equal to a square plus b square plus 2ab. The other identity is a minus b whole square is equal to a square plus b square minus 2ab. The third identity used for factorization is a plus b into a minus b is equal to a square minus b square. We shall use these identities for the factorization of algebraic expressions. We take one example of, say, x square plus 8x plus 16. To factorize this expression, you can see that it has three terms, like in the top two identities, and two terms are perfect squares, x square and 16. This algebraic expression can also be expressed as x square plus 8x plus 4 square, or this is x square plus 4 square plus 2 into 4x. This fits into the very first identity, and finally this is x plus 4 whole square. So factors of this algebraic expression is x plus 4 into x plus 4. Now we take another example. Say this is x square minus 10x plus 25. Here we see there are three terms and two perfect squares. So we can use the identities to factorize it. That is x square plus 5 square, this is 25, minus 2 into 5x. So from the second identity, that is a minus b whole square, we can put simply x minus 5 whole square. So the factors of this algebraic expression are x minus 5 whole square. Simply, if we look at one more example, that is say 4x square minus 9y square. Here we find there are only two terms in the expression and both are the whole squares. So this can be written as 2x whole square minus 3y whole square. Using the identity, this can be 2x plus 3y and 2x minus 3y. This is how we can do the factorization of an algebraic expression where two perfect squares are giving a negative sign between them, and we get the result of the factorization, and these are the factors of this algebraic expression. We have seen the expressions containing two perfect squares in them. Now if we encounter an expression of the form of x square plus a plus b x plus ab. Here there is only one perfect square and three terms. How do we do these things? This expression finally becomes equal to x plus a into x plus b. We take an example of x square plus 5x plus 6. To factorize it, we find that there are three terms but only one perfect square. Then we see the last term. The last term 6 can be expressed as 2 into 3. And when we add these two factors of the last term, we find that 2 plus 3 is equal to 5. That is equal to this term here. Now we can express this in the form of x square plus 2x plus 3x. This becomes equal to 5x plus 6. Now we do regrouping of the terms and take the common factor out, that is x plus 2, plus here we take common factor out 3, becomes x plus 2. Now we take the common factor out here, becomes x plus 2 and x plus 3. That's how finally this kind of algebraic expressions can be factorized, and the factors are x plus 2 and x plus 3. We shall take another example to explain that how these things can be, how the factorization can be done. In these cases, x square minus 4x minus 12. Here in this case, if we look at the last term minus 12, this can be expressed as minus 12 is equal to minus 4 into 3 or minus 6 into 2, also as 6 into minus 2. Now we look at the different factors of this. If we have minus 4 into 3, so the sum of these two terms, minus 4 and 3, comes equal to minus 1, which is not equal to this. Now we take minus 6 and 2. The sum of these two terms, minus 6 plus 2, will be minus 4. So we can decompose this term with as minus 6x and plus 2x. If we take 6 and minus 2, it becomes plus 4, which is not our intended number. So we decompose the middle term like x square minus 6x plus 2x minus 12. Now we go to the regrouping and take the common factor like x. Here it is x minus 6 plus x plus 2, and it becomes x minus 6 here. So the factors are x minus 6 and x plus 2. That's how we carry out the factorization in different systematic way. Now finally, to summarize, when we have any given algebraic expression, the first job we do is try to take a common factor. Take a common factor. The second thing, if there are no common factors, we regroup the terms. It is regroup the terms to take a common factor. And finally, if we cannot regroup, we use algebraic identities to factorize the given algebraic expression. The algebraic identities which are used can be simply summarized as x square plus y square plus 2xy is equal to x plus y whole square, then x square plus y square minus 2xy is equal to x minus y whole square, or x square plus a plus b x plus ab is equal to x plus a into x plus b. And also we can use this algebraic identity, that is x square minus y square is equal to x plus y into x minus y. So this is how we can carry out systematically the factorization of algebraic expressions.